Hey there everybody, in this lesson we're going to be talking about systems of equations and how to solve them algebraically. The two methods we're going to be doing here are substitution and elimination. This should not be new to anybody here. This is stuff that you have learned in Alg 1 and touched on a little bit in geometry. Some of you might have even learned it prior to Alg 1, maybe in middle school at some point. So this is just going to be kind of a refresher for most of you. So let's start off, shall we? Nice little warm-up problem here. We have a store is selling small notebooks for $8 and large notebooks for $10. Those are pretty expensive notebooks, but whatever. A student buys 6 notebooks total, so I'm going to make note of that. So we have 6 total notebooks, and then we spend $54 total. So they're giving me a quantity and a cost, so that's going to be important there. How many of each size did he buy? So this last sentence in all of your word problems, this last sentence is going to give you a hint as to how you can set up your variables. So it's saying how many of each size, so that's going to tell me my x and y should represent my smalls, and then I'll let y represent the larges. All right, so let's get 2 equations going. First equation is going to talk about just the total quantity of notebooks. So first equation we had, between our smalls and larges, we had 6 total notebooks. Second equation is going to talk about the cost. Well, we know we spent $54 total, so I know this is going to equal out to 54. And each small notebook was 8, each large was 10, so I could say 8 for every x and then 10 for every y. And now I've got my system of equations. So from here, we could go through and we could solve this using either substitution or elimination. If I personally were going to solve this, I would probably lean towards elimination simply because we've got both the x and the y. They don't have a coefficient or a number attached. So it would be super easy for us to kind of multiply this entire equation by something in order to cancel out x's, or we could cancel out y's and then work from there. All right, so now that we have the general idea of how to set these things up, let's get in the mechanics of solving. So let's start off with substitution. So substitution is going to be ideal anytime you see a variable that does not have a coefficient, or if you see a variable that's already isolated by itself on one side of the equal sign. So for instance, like x equals something, or y equals, it doesn't have to be x. So substitution, what you're going to want to do is make sure that your variable is isolated. So to get the x by itself, I need to kick the 3y to the other side. So it'll be negative on the other side. So negative 3y plus 5. Oops, there we go. And now that I have that, I'm going to plug in this expression for x into my other equation for x right there. So this will be negative 2 times the quantity, and we're going to plug in this whole shebang into there, minus 4y equals negative 5. All right, and let's go ahead and just plug that expression in there. I'm going to see if I can cheat a little bit here. Cool. Perfect. All right, so now this is just a 2 or 3 step equation that we can solve relatively quickly. Let's distribute our negative 2 into the parentheses here. So it'd be a positive 6y minus 10. Then we have the minus 4y equals negative 5. I'm seeing some like terms here with the 6y and negative 4y. Combine those, we would get 2y. And then if I move the 10 to the other side, hey now, there we go. That'll give me a positive 5 over there. So y equals 5 halves, or if you're glued to a calculator, that'd be 2.5. All right, so now that you know your y value, we're going to go back up to our other equation to figure out our x value. So this guy's going to get plugged in up there. And let's see what we get. So we'd have negative 3 times 5 halves, or 2.5, plus 5. So it'd be negative 15 halves, or negative 7.5, plus 5. So we would get negative 5 halves as my x value there. All right, now we can't just leave our answer written as an x equals and a y equals. We always want to write our answer as an ordered pair, or as a coordinate. So it's always going to be an x comma y value. So for this particular one, it would be negative 5 halves, comma, positive 5 halves. Or if you're hell-bent on using decimals, negative 2.5 and positive 2.5. Doesn't matter. All right, so that's substitution. Let's go on to elimination. Hey, there we go. So elimination, what you want to look for is two variables that might cancel each other out. So you want to have the same coefficient, meaning the same number attached, and one positive, one negative. So clearly the 2 and the 3 are not the same number, nor are the 7 and the 5. So from here what I'm going to need to do is figure out, can I turn a 2 into a 3 or a 3 into a 2? And no, I can't really do that. Could I turn a 7 into a 5 or a 5 into 7? And same thing, no, I can't really do that. So we're going to have to multiply both equations here. Now when we pick our variables to eliminate, I personally like to stick with whatever has the smallest coefficient. So here the 2 and the 3 are relatively small. I'm going to target those guys. So I'm going to shoot to eliminate x here. All right, well 2 and 3 both go into 6. So to multiply 2 by 3 would give me 6. So if I multiplied everything in this top equation by 3, that would give me 6x and 21y equals 12. I haven't really changed the value of the equation, I just kind of beefed it up by a multiple of 3. In that bottom equation, if I multiplied everything by, let's see, to turn a 3 into a 6, I'd have to multiply by 2, but I want it to be negative because they need to be opposites. So I'm going to multiply by negative 2. That's going to give me negative 6x, negative 10y, and then a positive 10 over here. All right, so now this is going to become the system that we solve, and you'll notice my x's should cancel each other out, right? They both have a 6 as the coefficient, but one's positive, one's negative. That's exactly what we wanted to happen. So we're going to add these two equations together. 6's knock each other out. They've been eliminated, hence elimination. Let's combine our y values. 21 and a negative 10, that would be 11y, equals 22. Divide both sides by 11, and we get y equals 2. All right, so now I know my y value. I need to find my x value. Well, I can use either one of these two equations. It does not matter whatsoever. I'm personally going to use the top equation here just because the numbers are a little bit smaller and there's no negative. You can do the bottom one. It doesn't matter. You'll get the same answer. And I'm going to plug in 2 for my y value here, and we'll work backwards to get the x. All right, so if I plug in 2 for y, that would be 14. So this is going to be 2x plus 14 equals 4. Let's move that 14 to the other side. 2x equals negative 10. So x is negative 5. And as always, we write our answer as a ordered pair. So negative 5, comma 2 would be our final answer. And again, you could have plugged 2 from this y value. You could have plugged it in up here, and you'd get the same answer, right? Because that would have been 10, and you'd get 3x equals negative 15. So x would still be negative 5 over there. Does not matter which one you choose to do. All right. Now let's try to solve something that does not have a unique solution. So this is going to be a scenario where there's either no solution or infinitely many solutions. It's going to be one of those two scenarios. Both of these are pretty well set up for elimination. So what I'm going to do is go through the first one here. Let me zoom in a bit. And I'm going to multiply that top equation by 2. So that way my x's can match up. So let me write that down here. That would be a negative 2x plus 2y equals negative 4. All right, so I kind of reimagine that top equation down there in red, so I can ignore that now. If I were to do elimination here, the x's cancel, the y's cancel, so I get 0 equals negative 4. Well, my variables are gone, and 0 equals negative 4 is clearly not a true statement. So anytime you have 0 on one side, so everything canceled, and a number on the other, that is going to give you no solutions. So that tells me if I were to graph these two lines would be parallel to one another. They're never going to intersect. All right, next one. Same idea. I want to use elimination in order to cancel some things out. Let's see, I'm going to get the x's to match up, so I'll multiply this top one by 3. If I put that down here, that would give me 12x. I guess it should be a negative 3. Negative 12x minus 3y equals negative 18. And when we combine those, the x's cancel, the y's cancel, so there's nothing on the left side, 0. And the 18's cancel. So there's nothing on the right side, also 0. Ooh, that's a wonky equal sign. There we go. Anytime you have 0 equals 0, meaning everything is canceled out, that tells you you have infinitely many solutions. Or graphically speaking, these would be the exact same line. So you'd have one line directly on top of the other line. All right, now let's get into some word probs. First one, we have a music store offering piano lessons at a discount for customers buying new pianos. And we can kind of gather some information over here in the graphic if we wanted to. So we have a cost per lesson, and it looks like there's also some mysterious one-time fee that we don't really know. All right, so let's generate a system of equations. So we're going to have to write out two equations, and then from there we can solve it. Let's see. I need to know the cost of each lesson and then the one-time fee. So I'll call the cost of each lesson, we'll call that X, and then the one-time fee, we'll call that Y. So scenario 1, we've got 6 lessons, so 6x plus that mysterious one-time fee, which is Y, equals 300. Scenario 2, we'd have 12x plus that one-time fee, and that's going to equal 480. Now, some of you might be tempted to do some substitution because we have a y all by itself here or here, but I'm going to lean towards elimination because if I just make everything negative on that top equation, these y's are going to cancel out quite nicely. All right, so if we do that, we're going to get negative 6x plus 12x, that's positive 6x, y's are gone, equals 180. So x is going to be 30, and that represented the cost of each lesson. So each lesson is going to be $30 per lesson. So $30 per lesson. All right, now let's get into that one-time fee. What's that about? Well, if x is 30, I can just plug in 30 for x right there, and then figure out what y is. So I have 6 times 30 plus y equals 300. And the only reason I chose that first equation is the numbers are smaller and I'm feeling lazy. we would have 180 plus y equals 300. Let's kick 180 to the other side to get y by itself. We would get y equals 120. And y represented, let's see, that one-time fee. All right. Let's move that over here. Now for this one, we're not going to actually put our answers in the form of an ordered pair. We're not going to write it as an x comma y because these aren't coordinates on a graph. This is an actual application problem, so each value for x and y is going to represent some particular aspect. So this is where you want to include that label of the dollars. So we have dollars per lesson and then that money for a one-time fee. All right, so we're in the home stretch here, folks. Here we go. Suppose you have a part-time job delivering packages. You've got a flat rate fee of $9.50 per hour. You discover that someone else is going $2 an hour and then $3 per delivery. How many deliveries would we have to have? Ooh, in 4 hours. So they're giving us an hourly rate. That's important for a 4-hour shift. So let's go. Scenario A is the flat rate of $9 an hour. Well, if it's $9 an hour, or sorry, $9.50 an hour, and we work for 4 hours, we can get that relatively easily. Just do 9.5 times 4. That would be $38. Scenario B says that we are going to be going $2 an hour, so $2 for 4 hours, plus $3 per delivery, and we don't know how many deliveries we had. So that's going to be 8 plus 3x there. And the question is asking, how many deliveries would you have to make to get the same pay in a 4-hour shift? So I want to know how many deliveries for x would I have to get so that these things essentially equal out. So 38 equals 8 plus 3x. That's a pretty straightforward equation to solve. Let's scoot the 8 over. Get 30 equals 3x. So x would equal 10. And that was 4 deliveries. So 10 deliveries. All right, and here we go. Let's end on this one. We're going to do some error analysis here. We have another word problem. We spend $4.30 on yogurts and juice boxes. A friend spends $2.60 on yogurts and juice boxes. What's the cost of one yogurt? What's the cost of one juice box? All right, so here they have the work. Let's see, the first scenario was $4.30 for 3 yogurts and 2 juice boxes. So it's looking like this one right here. Judging by their work, I'm going to say they're saying yogurts are y, and then juice boxes were x. So that equation checks out. And then the second scenario, $2.60 for 1 juice box and 2 yogurts. Should be this guy right here. Let's see if that still holds true. 1 yogurt. Oh, there we go. So right here, this is our issue. They swapped up their variables, so they had their x's and y's backwards for that one. So the second equation should read 1x plus 2y equals 2.6. And then we could go through and solve accordingly. All right, that is it. That is all for this lesson, folks. Don't forget, you've got yourselves a lovely little Math Excel to do today. If you have any questions, please don't hesitate. Let me know. Good luck, have fun, be safe, roll tide.